Okay, now we're going to have a look at question 8. Okay, question 8 I have across 2 sheets. So it's going to be a little bit difficult, but I'll flick back and forth for us. What I will do is I will do the working out here for us. Okay. As some of it's gone off the page, but that's fine. So, the Singh family and Patterson family go to the cinema. I've got the Singh family buy 2 adult tickets and 3 child tickets, and they pay this much. Patterson pay 3 adult tickets and 5 child tickets. The cost we need to find the cost of the adult ticket and the child ticket. Now, we might go, I don't really know, I'm not sure how to do this. Again, we're going to start using algebra to do this. Okay, we're going to start making sure that we're using our mathematical knowledge to start applying. So, I'm going to use the Singh family first. 2 adult tickets, and I'm going to call that A. And 3 child tickets, I'll call that C. And they pay £28.20. If I use the Patterson family, okay, draw a line there. The Patterson family have got 3 adult tickets and 5 child tickets, and they pay £44.75 for there. Okay. Now we should see straight away that these are simultaneous equations. Okay. What I want to do is get to a point where one of the variables has the same coefficient in both equations. At the moment, that's not the case. So I'm going to make C the same in both equations. I'm going to multiply the top one by 5 and the bottom one by 3 to do that. Okay, that's going to give me these 2 equations. Okay, underneath. So this one first is going to be 10A plus 15C, and I need to do £28.20 times by 5, and I can use my calculator to do that. Is 141. I can then do, and this is going to be 9A plus 15C equals 44.75 multiplied by 3. 134.25. Now, once I've got these 2, I've got these 2 as the same. That's what I wanted to do. So I need to think, right, how do I get rid of this for both equations? And because they're both positive, I've got 15C in one and 15C in the other. If I take them away from each other, I will get rid of this. So 10A minus 9A is 1A. This becomes 0. And then I do 141 minus 134.25. And I get 675. Okay, that's 1 adult ticket is 675. So right away I've got an answer here. Adult is 675. And I'm going to put pounds there, so I've got a nice clear answer. Regardless of whether you got this same answer, hopefully what you will have done is just plug this back into one of the equations, because we know that's going to get you another mark every single day of the week. So I'll put it back into this first one. So using the Singh family, I've got 2 lots of 675 plus 3 lots of C equals 2820. So 675 times by 2, move that a little bit so you can see it, gives us 1350 plus 3C equals 2820. So I know that 3C, because I can take away 13.5 from both sides, is 1470, which leaves me the final bit of this calculation, which is just doing 14.7 divided by 3, okay, which is £4.90. Okay, so we should have 675 and 490. Hopefully you'll have more space, so it will have been slightly clearer for you, but nice and easy. Okay, that's question 8 finished. Now let's have a look at question 9. Question 9 is this one. Okay, again, it's one I've had to draw on just to make sure it's really clear. So if you're unsure of what I've written, then make sure you've had a look yourself at your own paper. I've got bits of information here that are really important. A, B, C, D, E, F, G, H, which is the shape around the outside, is an octagon, which is 8 sides. Okay, these 2 smaller ones are pentagons, which are 5 sides. Okay, and I want to find the angle marked x. Okay. So I'm going to think about what I'm going to need to find to do that, to find the angle marked x. There's a few ways I can do it, and I need to identify a few things about it. X here is around a point, so we've got this, this and this are all little bits of information. I've also got this in a triangle here, okay? Now, because these two are regular, I know that that's the same as that, which is same as that, which is same as that, 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 same as that. So this triangle is isosceles, okay? We can always redraw things. That's an isosceles triangle. Now I'm going to focus on trying to use that, I think, to find, and that means I need to find this bit. I'm going to call that y. Because it's isosceles, I know that, yeah, both of those are going to be y, and they're going to be the same angle. Now, what I can start doing is starting to think about this in total, and because I've got polygons like this, got regular polygons, I'm going to be straight away thinking about interior and exterior angles. What I'm going to show you is this angle y that angle y can be found using this angle, which is the interior angle of a pentagon, okay, and this total angle, which is the interior angle of an octagon. So, interior angles, to find the total interior angle is n minus 2 multiplied by 180, okay, multiplied by 180. For the octagon, 8 minus 2 times by 180, 1080, yeah? So one of those angles, divide that by 8, and I get 135. So, to find y then, I know that y plus this angle here, which is the interior angle of a pentagon, this one here, will equal 135. So let's do a pentagon. n minus 2 multiplied by 180 equals, now that's 3 times by 180, which is 540. Might be worth labelling those as well. Octagon, pentagon, 540. Divide that by 5 because there's 5 sides. It's 108 degrees. Now, as I've said, this is 108 degrees now. I know that in total it's 135, so I can say that y, using this diagram, that y equals 135 minus 108, which is 27. If that angle there is 27, then to find x, x equals 2y, sorry, x is 180 minus 2y, okay? So it's 180, because of angles in a triangle, so 180 minus 27 twice, which is 126 degrees, and that's my final answer. Okay, there's angles in angles in polygons for this whole question. Okay, this comes from this up here. I'm saying this is 108 x here because it's in a triangle. X plus y is 180. Okay, I've already said that y is 27. So to find x, I need to subtract 27 twice from 180 and get 126 degrees. Okay. Now, question 10 is recurring decimals. Now, this is 0.178, so I've got 0.178 recurring, and it says prove algebraically, so I'm going to say x is this straight away. I need to remember that the thing I'm trying to do is get everything after the decimal point to be the same. The recurring bit is going to stay after the decimal point. So I want to move this 1 to begin with, so I'm going to multiply it by 10, and I'm going to get 1.78. recurring. That's good, so I've got a recurring bit here. And if it's recurring, it will be the same as long as the next bit is recurring as well. So now, because I want after the decimal point to be recurring, I now need to make sure I'm going to multiply this by another 100. This needs to move another 2 places. So 10x times 100 is 178.78 recurring. 10x times 100 though is 1000. So it's 1000x is 178.78. Now I'm going to take this away from it because they've both got the same thing after the decimal point. So 10x is 1.78. Now this is why I've done it, right? I want to get rid of everything after the decimal point. That's why I've lined these up. So 7878, they line up, so they're going to just both cancel each other out for infinity. And then all I'm going to be left with is 178 minus 1, which is 177. Yeah? Now, this side, 100x times by minus 10x is 990x. This means that x equals 177 divided by 990. Okay, I'm just going to divide through. That is this written in as a fraction, but I'm asked to show that it's in this form, 59 over 330. Now if we're clever, we'll go, right, 330, this is 990. I need to divide top and bottom by 3. Okay? If I do 177 divided by 3, I get 59. Oh, sorry, I've just written 990 again. Okay, done. 59 over 330. Sorted. Key thing is to make sure that everything after the decimal point lines up, because then when you do the subtraction at this point, okay, when you do the subtraction, you're going to get rid of everything. Everything after this decimal point is going to disappear, which just leaves us with nice numbers again. Right, one more to have a go at, which is question 11. Okay, question 11. It says it would take 120 minutes to fill a swimming pool using water from 5 taps. How many minutes will it take to fill a pool if only 3 of the taps are used? Okay, so we're filling something up. I want to say that 120 using 5 taps. Okay, 120 minutes. This one, I'm going to do it down here actually. 120, and that's 5 taps. So I want to know what happens with 3 taps. The important thing here is I need to think about, right, 5 to 3 doesn't work that easily, so I'm going to down to 1 tap. Okay, I'm going to think about what happens to 1 tap. What happens if I reduce the number of taps? This, which is the time, needs to get longer. It will take more time if I've got less taps. Okay, so while I divide by 5 here, I need to multiply by 5 here. Okay, so I'm going to do 120 times by 5, and I'm going to get 600 minutes for 1 tap. Now I'm increasing the number of taps, multiplying that by 3. Now if I have more taps, this needs to get smaller again, so I'm going to divide it by 3, and I get 200 minutes. Okay, simple as that. This is inverse proportion because when this one goes down, this one goes up. The big mistake is people will just do the same on both sides. So this needs to be 3 taps. Okay. Oh, sorry, 3 taps is 200 minutes. It then asks me what assumption I've made, and the key thing here is that the water leaves each tap at the same rate. Done. Well done. I hope that was useful, and any questions, obviously, please do let me know.